Jai Hind everyone, myself Ankita, Faculty of Department of IT, AKGEC. Today I am going to discuss Unit 3 of Big Data course KOE 097 Hdfs, that is Hadoop Distributed File System. I will be discussing the introduction to Hdfs, features of Hdfs, advantage and disadvantage of Hdfs, architecture of Hdfs, blocks in Hdfs, and finally the rack awareness algorithm. Now, what exactly is Hdfs? So we have studied in this course so far that big data Hadoop is the solution to all big data problems, that when we want our large data to be processed, we need to store it in such a way that whenever more data comes, we are able to accommodate that data. Now this is done by your Hdfs of Hadoop, that is Hadoop Distributed File System, where we are storing the data across various commodity hardware. Now these commodity hardware are lesser in cost as that of servers. So Hadoop file system is a distributed file system which is designed to run on commodity hardware. It is highly fault tolerant and is designed to be deployed on low cost hardware. So when we are talking about commodity hardware is basically a low cost hardware. Now it is fault tolerant. Why it is fault tolerant? Because whenever we are using a concept of replication, so a same data is replicated across various nodes. So if any node fails, we are able to access the data from other nodes. So therefore, Hdfs is highly fault tolerant. Also, Hdfs provide high throughput access to application data and is suitable for large data sets. So Hadoop provides your data storage for Hdfs provides data storage for Hadoop. So where Hadoop splits the data into smaller units called block, we can store them across various data nodes in a distributed manner. So we have two daemons, that is one for the master node and other for the slave nodes. For master node, we have NameNode, whereas for the slave node, we have DataNode. So what we are doing, we are dividing the data across various nodes, and these nodes are called as data nodes, and these data nodes are your slave nodes. Now all these slave nodes are managed by one master node, which is known as your name nodes, right? Now, what are the features of Hdfs? First and foremost important feature is distributed storage, where we are storing the data across different data nodes or in a distributed manner. What it ensures parallel processing that we have discussed. As MapReduce we can apply, and by parallel processing we can speed up our computation time as well as your fault tolerance. Now, since the data is replicated into 3 copies across different nodes, so if one node fails, we still can access the data from other nodes. This is known as your fault tolerance. Now, when we are distributing the data across various nodes, it's possible for us to do parallel processing on them. Therefore, we reach a high throughput in your Hdfs. It supports large file systems because we can store the files of gigabytes and terabytes in size. Then another important feature is write once and read many model. So Hdfs is a data in your Hdfs can be only written once, though it can be read multiple times. So it simplifies the data coherency and improves the performance. Scalability is easy to scale, as we discussed that Hdfs provide you horizontal as well as vertical scalability. So suppose I have an X amount of data, I am storing it into my N nodes. Now if my data has increased from X to X plus 1, what I can do, instead of increasing the capacity of my N nodes, I will add another node which will take care of the extra data. So that is your scalability. Data locality, here we are not bringing the data to the logic, rather than we are bringing the logic to the data. So that is also a feature of your Hdfs. Also, we have a master-slave architecture in your Hdfs, where we have a master service called as NameNode, and a slave service that is called as your data node, which are actually storing the data blocks. So what are the advantage of HDFS? We can store the large data sets in a very good manner. So it is, since HDFS is built for storing the large data sets. Next is fault tolerance. HDFS is designed to be fault tolerant. If some error occur at any of the nodes, we are able to recover from that. Scalability, HDFS provides the horizontal as well as vertical scalability. Then we have simplicity, that HDFS has a simple design that it makes it easy to implement and maintain. So these are the advantages of HDFS. Next is your disadvantage. First is it is slower than other systems. So HDFS is not fast as your local file systems or NTFS that we use in our local computers or personal computers. Now this is due to the fact that files are replicated across multiple nodes. So we are getting advantage that we are getting fault tolerant system, but there is a disadvantage that it becomes slower because we are storing the data across various nodes. We are replicating the data. So each time they have to find out, yes, I have to contact this node and I have to see other nodes as well, which are having same data. Also, data compression is not used by default in HDFS, which further impacts the performance. Second disadvantage is that it is not suitable for small files. So HDFS is not optimized for storing and retrieving numerous small files. So we are not able to store the small files as efficiently as we are able to store the large files in your HDFS. So when we move on to HDFS concept, simple, we have a master slave architecture in your HDFS. We have a master service called as NameNode, whereas and the slave service as your data nodes. So, the purpose of NameNode is to maintain the file system namespace, whereas data nodes actually stores the data. So, HDFS exposes a file system namespace and allows user data to be stored in the files internally. Now, the file is split into various blocks and these blocks are stored in your set of data nodes, right? So, NameNode will execute the file's namespace operation. It is like a manager. It will see that which data, which block is stored at which node, how to access that data, how to open the access to the data, how to close the access to the data, and how we are renaming files and directories. It also determines the mapping of blocks to data nodes, how these blocks are mapped to the data nodes. Also, data nodes are responsible for serving read and write requests. So basically, we have a data node and we have a name node. Name node manages which data is present at which data node, whereas actual work is done by your data node. Now, when we see the architecture, we can see we have a name node which consists of metadata. Metadata means that which block is located at which data node. If I want to access to a data, what I will do, I will come to the name node. I will say, yes, I want this data. Name node will find out for me that that data is located at which data node. It will tell me the location and also it will keep track, yes, now this node is already being used by this node is already being used. Now, data node will actually have the data blocks with them. And also, please keep in mind that the data blocks and data nodes are replicated multiple times. So, I have this data which is replicated at this node and as well as this node. That is, data replication is also done. And this is all managed by your name node, that how my data is divided and how my data is replicated. All this information is managed by your name node. So, Hadoop distributed file systems follow a master-slave architecture with each cluster comprises of single master nodes and multiple slave nodes. Also, we are dividing the data into blocks and each block is saved into a set of slave machines which are known as data nodes and they also replicated. So, if my replication factor is 3, by default the replication factor in Hadoop is 3. So by default, my data will be divided into 3 parts. Replicated into 3 nodes. Whereas master node stores and manages a file system namespace, slave node stores the data. Now, when we talk about name node, we can see we have a name node and we have a data node. Now, what does the name node have? The name node first of all manages the file system namespace. It says that since I have this file and I am dividing this file into multiple blocks, and these blocks will be stored at various data nodes. Now, what are the location of this data node is, what are the location of this data node? This information is present with your name node. So, name node store information about the block location, that where my block is located, what are the permissions to access that blocks. Next, we have 2 information, that is fs image. Fs image is your file system image which contain the complete namespace. Whereas edit log consists of all whatever changes that we are making on the file system, this is stored at your edit log. Now, this is very important. Fs image consists of all the information about the namespace, whereas if there is any change that is made in the namespace, that is stored in your edit log. Now, the features of HDFS name node is that the name node manages and maintains a data node. That is very primary feature of name node. And also it manages, executes the operation like opening, renaming and closing the files and directory. So it will help you locate the file. It will help you open the files on the nodes. Second is also it takes care of the replication factor. How many times I need to replicate my block. Next important thing is that now when I am replicating my data across various nodes, now how will I know that if I got a read request for that data, how will I know that where I have to, send a read request to that node? For that, I keep track of heartbeat and block reports. Heartbeat means that each node will tell it that, okay, I am working properly. It will send a heartbeat after a frequent intervals, so that the name node will know, yes, these my blocks are working properly and these are the blocks they are possessing. So, block report consists of all the blocks a data node has present. Now, what is the function of data node? It actually is an inexpensive commodity hardware which stores the data, okay, which actually stores the data, which manipulates the data. The actual work is done by data node, whereas name node is just managing the data. Now, data node is responsible for serving the client read and write requests. Actual read and write request is, catered by your data node. Also, based on the instruction of name node, it creates block, replicates the blocks and also delete. Data node also send the heartbeats and block reports to the name node so as to tell, yes, I am functioning properly. Second, these are the blocks that I am possessing. Next concept is of secondary name nodes. So, prior to Hadoop 2, we had only one name node. But what was the problem we were facing with only one name node? Now, when name node is functioning for the long amount of time, what happens is that log files, the edit log becomes so huge that whenever the name node starts, it takes a lot of time to incorporate those changes with them, right? So, therefore, to combat that issue, we have introduced a secondary concept of secondary name node. So, secondary name node is a similar daemon which is functions same as that of your name node. So, whenever name node starts, the name node merges the fs image and edit log files to restore the current file systems. Now, what happens when it runs continuously for a long time without the restart, the edit log size increases. So, what will do? It will take more time to restart. So, secondary name node solves this issue. Secondary name node downloads the fs image files and edit logs frequently, and it keeps on updating its fs image from the edit log. So, whenever a name node restart, it takes its fs image from the secondary name node. So if the name node fails, a secondary last FS image of secondary name node will be taken care of. So we have increased our fault tolerance of your name node as well. Earlier we were just replicating to ensure the fault tolerance. Now we have also taken account that if my name node fails or if my name node have to restart, it doesn't take high time to restart with the presence of your secondary name node. Next concept is of your high availability, that is HDFS high availability. Each cluster has a single name node, and if that machine or process become unavailable, we can get our information from your secondary name node, right? So in case of unplanned event or machine crash, what we can do? We can switch on to our secondary name node. And also in case of planned maintenance, we can use the secondary name node. So this is the same feature. It is available from Hadoop 3.0. Okay. So that is your secondary name node, or which ensures high availability. Now another node that we have introduced, that is standby node, which ensures your high availability was secondary name node, and other one is your standby node. Now standby node, it fails over happen. Standby ensure that it's fully applied to the all edits becoming the active. So standby node, what we do is it take all the information from the primary name node and keeps on updating itself. Now whenever there is a failure, what happens? That we are getting the data from the secondary node. So data nodes are aware of all name nodes and send the block locations and heartbeat to all of them. Next is your blocks. Now a block is nothing but a smallest unit of storage on a computer systems. So whenever we are storing the data, we are storing it in the form of blocks, and the default block size is 128 MB or 256 MB. Suppose we have a data of 700 MB, so we are divided into 6 blocks, right, of 128 MB each. So remaining, so if I am having a 700 MB data, I will divide it into 128 blocks. So I will be having 1, 2, 3, 4, 5 blocks, and the remaining data of 60 MB will be kept in your next block. So this is how we are keeping the data. Now why we are keeping such a huge size for our HDFS block, that's 128 MB. Now the first reason is to minimize the cost of seek. So when a data is written to a disk, there is a time delay in moving the disk read and write. So when we have larger blocks, we will have lesser frequency of seeks. So it will make our process faster. Also, if the blocks are small, there will be many blocks, and to store the metadata of these blocks is then our name data FS image will be very much huge. That is not what we want. So the purpose of keeping the block size as 128 MB is to two main purpose. First is to minimize the cost of seek, and second is to reduce the HDFS name node metadata size. Next is your replication management. Now to provide fault tolerance, HDFS use replication technique. So when we have a data, I will be replicating that node across various nodes, replicating that data block across various nodes. So to provide the fault tolerance, HDFS use replication technique, and by default the replication factor is of 3. So we can say if we have storing 1 GB of data, we have, and the replication factor is 3. So we will be using 3 GB of data. To maintain the replication factor, NameNode collect the block report which says, yes, each data node tells that these are the blocks I am having with myself. Okay. So whenever a block is over replicated or under replicated, the NameNode adds or delete the replicas accordingly. So a block report contains a list of all blocks in the data node. Now this is how we are configuring the replication factor in your HDFS site.xml file. Now next topic is your rack awareness. Now when we are replicating the data, we are putting it into different data nodes. Now these data nodes are stored in racks. Like these data nodes are kept in rack 1, these in rack 2, and this in rack 3. Now, if I have a data node, okay, which is having a block B1. Now, my replication factor is suppose 3. So, I will be storing my block B1 over here. Or if I am storing the B1, I am storing all the block in same rack. Okay. And suppose this rack failed. So, all of my blocks will get lost. So, to prevent that, what we do is we are distributing these blocks into various racks, so that even if one rack fails, I can get my data from other racks. So, HDFS follows a rack awareness algorithm to place the replicas of the blocks in a distributed fashion. The purpose of dividing the blocks into different racks so as to ensure low latency and fault tolerance. So, if my rack fails, and I can get my data from other racks. So, what is the need of rack awareness algorithm? First is it improves the fault tolerance by ensuring the replicas of a block are stored on different racks. So, if my one rack fail, I can get my data from other racks. Second is it enhances the network performance by placing at least 2 replicas on the same rack, minimizing the cross traffic during read and write operations. So, it also enhances the network performance. It is keeping 2 replicas on the same rack. Third important thing is it enables the efficient resource utilization by allowing NameNode to make smarter decisions about where to place data and balancing the node and reducing the impact of rack or node failures. So, that was your need of rack awareness algorithm. So, in this video lecture, we have discussed about how we are storing the data in a distributed manner in your HDFS. Then, what are the architecture of HDFS? That we are having one name node that is managing the all namespace information, whereas we have data nodes which are actually storing the data. Next, we have understood how we are ensuring high availability by replicating your name node into a secondary name node, which consists of all the information as of your primary name node. Then we studied about data nodes. We also studied about blocks. What are blocks? How we are keeping the data into different blocks and how these are replicated. We also studied about replication. And next, in the last topic, we discussed about rack awareness algorithm. That is how we are, placing these blocks of data across various racks so as to ensure that we are to ensure our network performance, fault tolerance, and efficient resource utilization. So, this is all for today. Thanks.